Okay, let's dive into something truly fascinating today. Imagine a financial market that reached nearly, 25 billion back in 2020,
That's right.
and it was still growing at double-digit rates.
Yeah, huge numbers. We're talking about the European debt purchase market. It's a massive, absolutely crucial part of the global financial sector.
A massive landscape.
It really is. And our mission today is to explore how cutting-edge machine learning is. Well, not just entering this industry, but fundamentally transforming it.
Right.
We're looking at a new modeling pipeline, one designed to make predictions incredibly accurate, reliable, trustworthy, and it's been validated with real-world historical data.
And at the heart of this, for anyone, working in finance or studying operations, there's this one critical challenge. Accurately estimating who will pay their debt, and maybe just as important, when they'll pay.
Exactly.
Getting that right isn't just like a minor detail, is it? It's central to strategy resources.
Oh, absolutely. Central to revenue, everything.
So what's the sort of holy grail in this system?
That's a good way to put it. The holy grail here revolves around two key predictions. First, a debtor's propensity to pay, which we can just call PTP.
PTP.
And second, their expected cash flow.
Okay, break those down a bit. PTP is like the chance they'll pay soon.
Essentially, yeah.
Yeah.
The probability a debtor will make a payment within a certain time frame, let's say the next week.
Got it. And expected cash flow.
That's more straightforward. It's the amount of money a company can realistically expect to recover from that debtor over time.
So it's not just about, chasing everyone equally.
Not at all. It's about smart, targeted action.
Makes sense.
And these estimations are absolutely crucial. Vital for ensuring adequate returns in the whole debt collection process.
How so?
Well, they allow companies to design different targeted strategies. For instance, during what's called amicable collection.
That's trying to sort it out without lawyers, right?
It's exactly. Working out a payment plan, that kind of thing.
Yeah.
But these predictions also help prioritize which cases need legal action. Maybe where debtors are just unreachable.
Right.
Getting these predictions right, it can lead to really significant increases in cash flows.
Like how significant?
We could be talking hundreds of thousands, maybe even millions of euros. It really transforms a reactive process into something highly strategic.
Okay, so we can see why nailing these PTP and cash flow predictions is absolutely critical. Huge for the bottom line. But here's the kicker, isn't it? Just making a prediction isn't enough. Especially in finance, where, every little bit counts. How do you know you can actually trust that prediction, that probability?
Exactly.
Which brings us to this challenge of probability calibration.
Precisely. Calibration. Think of it like this.
Yeah.
If your model says there's a 70% chance of rain, does it actually rain 70% of the days when it made that prediction?
Okay, yeah.
Now, traditional ways to assess this, things like reliability diagrams or metrics like ECE, expected calibration error, they sound pretty solid.
They sound technical, yeah.
They do. But the research highlights a fundamental flaw. ECE relies heavily on something called binning and counting.
Binning and counting. Okay, use that dart player analogy you mentioned.
Right. Imagine you're judging a dart player. But instead of seeing exactly where each dart hits, you just draw, say, 10 big, equal-sized circles on the board, arbitrarily.
Okay.
And you only count how many darts land in each broad zone. Now, what happens if you change the number of circles? Make them bigger or smaller?
Yeah, the score you give the player could change completely.
Exactly. Even if the player's actual skill, their performance hasn't changed at all.
That seems problematic.
It's very problematic for ECE. The metric shows extreme dependence on the choice of bins. You get significantly different values just by changing how you set up those bins.
So the person doing the analysis could basically tweak the results?
Whether they mean to or not, yes. It allows analysts to potentially fudge results, make things look better or worse just by changing the bin setup.
That doesn't sound reliable at all, especially for automated systems.
It's fundamentally unreliable for that.
Yeah.
Which leads to the big question. How can you possibly trust a metric if its output changes based on these subjective choices, not the actual model quality?
Right. It undermines the whole point. So if ECE is like using that blurry adjustable target, what if there was a better way? Like using a laser precise fixed ruler instead?
That's exactly what this paper proposes. It introduces these innovative new metrics.
ECE MAD and ECER.
Correct. ECE-MAD is the maximum absolute deviation of the empirical cumulative calibration error, and ECCER is the range of that error.
Okay, mouthfuls aside, what do they do differently?
Well, what's really revolutionary about these ECCE metrics, they're fully non-parametric, meaning they don't make assumptions about the data's distribution or the error's shape. Think of it like a universal tool. It works regardless of the specific situation.
Okay, more robust.
Much more. They're also uniquely specified. There's only one way to calculate them. No subjective choices involved.
Removes the tweaking problem.
Completely. And crucially, they assess calibration without any specific trade-off concerning binning. You don't need huge sample sizes. You don't set arbitrary parameters. They just give you trustworthy results. Much more robust for automatic solutions, which is vital if you want to deploy this in the real world.
Okay, that sounds like a genuine breakthrough in measurement. So how do you take these powerful new rulers, these ECCE metrics, and build a smarter automated system for something as complex as debt collection?
Right, so the research proposes this advanced machine learning pipeline. The goal really is to consistently find and use the best possible PDP model to guide the day-to-day operations, all automated, without needing constant manual checking.
Makes sense. How does the pipeline work?
It's a few key steps. First, you have a model generator. This creates and fine-tunes various machine learning models, lots of different types.
Okay.
Then, very importantly, you estimate their performance rigorously using k-fold cross-validation.
That's to make sure they work on new data, right? Not just the data they were trained on.
Precisely. It's like giving the model several different mini-tests on unseen data parts. Ensures the performance isn't just a lucky fluke.
Good. And the last step?
The last step is the model selector. This applies those new ECCE metrics, and for this specific industry, they found ECCER was particularly suitable to pick the best calibrated model from the bunch.
And I remember reading the model generator uses something specific. Strictly proper scoring rules. What's that about?
Ah, yes. Strictly proper scoring rules. Things like the Breyer score or the logarithmic score. These are basically special math functions used during the tuning phase we call hyperparameter optimization, fine-tuning the model's internal settings.
And why are they proper?
Well, what's really appealing, especially with a logarithmic score in finance, it imposes a high penalty when the model is overconfident about an outcome and it fails.
So it punishes bad predictions more harshly if the model was really sure?
Exactly. It helps avoid situations where, let's say, the true probability of someone paying is maybe 1%, but the model confidently predicts 0.01%.
That sounds like a small difference, but...
In finance, that tiny error can mean huge misallocations, big losses. The log score really discourages that kind of overconfident mistake. And the chosen metric, ECCER, gives you the solid bound of the total miscalibration, a clear number telling you how well your probabilities actually match reality across the board.
Okay, theory and pipelines are great, but the real test is always performance in the wild, isn't it?
Always.
And they did test this on real data.
They absolutely did. The pipeline was implemented on a massive real-world data set, proprietary data generously provided by an important debt collection company.
How massive?
Over 156,000 records, real debtor and debt data from August 2022 to April 2023.
And the goal?
The specific goal was estimating that propensity to pay in the next 7 days for each debtor. Very practical.
So what did they find when they actually ran the models through this new pipeline?
Well, they tested several models, like GBM, which is a popular algorithm, both uncalibrated and then calibrated using different methods, Platt, isotonic, and spline calibration.
And the winner was?
The results were pretty compelling. The light GBM model combined with spline calibration came out on top. It was selected as best based on both ECCER and that logarithmic score we talked about. It just showed better overall performance and less miscalibration. Consistently better.
And how did this compare to using the old ECE metrics?
That's where it gets really interesting. When they looked at the traditional ECE1 and ECE2 metrics, those older metrics gave completely different and frankly erratic rankings. Depending on how many bins you used, the best model changed.
Seriously?
Yes. ECE even suggested sometimes that Platt calibration was better than the uncalibrated model, when the ECCE metrics clearly showed the opposite, with much more confidence.
So the old metrics weren't just less precise, they were actively misleading.
In this case, yes. They were unreliable for making the right choice.
Wow.
But crucially, this wasn't just, a theoretical exercise on a data set.
They actually used it.
Yes. An experimentation phase was done in the company. They put the winning model into production, used it for a limited set of real cases.
And the outcome? Did it work?
It did. The new PTP model, the one selected using ECCER, managed to increase in the experimental phase the collection success.
They measured that properly.